Hey guys, this is Mr. Sal. We're going to look at Module 3, Lesson 2, which is the coordinate system or just graphs, which you can see right there. So thanks for watching. Don't forget to like and subscribe, and comment about what you think about the lesson below. 3.2, graphs. Now this is a different graph, right? Before, when we were looking at graphs, it was just a straight number line. This one is not only a horizontal number line like we've been dealing with, and yes, that is the x-axis, but it is also a vertical number line right here, which we identify as the y-axis. Okay, so we're looking at two different values, and we kind of talked about ordered pairs last time when we talked about domain and range stuff. In any case, as we can see from this point right here, 1, 2, the 1 is the x value, and then the 2 corresponds with the y value. Both of these together make up what we call an ordered pair. And then, yeah, they gave us the y-axis and the x-axis. It is possible that you may see that circle right there when you look at a graph. And you may interpret that as a 0, but it is not a 0. It's an O, which stands for origin. Okay? I put x value and y value. You could also identify them as x and y coordinates. It doesn't really matter. What does matter, though, besides that, is the quadrants. As we can see with the two number lines splitting things up, we have 4 parts to this, and we call those quadrants. This is quadrant 1, this is quadrant 2, this is quadrant 3, and then quadrant 4. Why is it numbered like that? I don't know. Why do we write them in Roman numerals? I don't know. Maybe the Romans came up with this garbage. But someone did, and they used Roman numerals, so we use them as well. One thing that may be helpful on this is quadrant 1 has positive x and y values, and since we like to start out with positive values, maybe that's good to remember that as quadrant 1. So we start in quadrant 1 with only positive values, and then we work our way around. Quadrant 4, well, it has positive and negative, so maybe that doesn't help. All right, number 1 here, for some reason. Find the coordinates of each point plotted below. Well, let's identify the points. We got point A. Oh, that's a little big. We got point B, and C, and D. Now you could put equals or a colon right there. All of these are going to include some set of parentheses, though, to show the ordered pair or coordinate pair, whatever you want to call it. Let's look at A. On A, so I'm starting at the origin right here. And remember, the first value is the x value. So I've got to go horizontally on this. Starting at 0, I would go back 1, which puts me at -1 right there. All right? And I can see that A is lying on this line, which represents x is -1. Well, from there, I've got to go up 1, 2, 3, and that was in the positive direction on this vertical number line. So the ordered pair, or the coordinates, are -1, 3 for A. All right then, B. The x value is at 2, and then it goes up 1, so that's a +1 for our y value. Now let's try to look at this a little differently. So C, right? I can show x value here and then y value like this, kind of creating a little box, a corner of a box. Well, the x value right here is at -5, and the y value is at -2. Bam, that's it. Now we could, just as a review, ask, does this 4 points, if it were a set, would it give us a function? Yes, yes it would. Because none of the x values repeat. Well, that's first of all. That's all we really need on that. Plot the points, determine which quadrant or axis each point is on. Okay. So we got this first point. It's not really labeled, but we'll put it in there. In red. At negative 4, 5. Now the lines on this aren't numbered, but we should be able to identify them because we know that the center of the two axes coming together is the origin. Now this one is at negative 4, 5, so I've got to go to the left 4. 1, 2, 3, 4. So on this vertical line, once that shows up, there we go. This vertical line, we know this point is going to be on that vertical line somewhere. Also, the y value is at 5, so I got to go up 5. 1, 2, 3, 4, 5. And then it's where those two connect that we're going to make that point right there. So this point right here. And yeah, we'll label it negative 4, 5. The next one at 0, negative 2. Oh, wait, let's go back on that. That red one, right? What quadrant is this in? Yep, this is in quadrant 2. Right, because we know this is quadrant 1, and then it's counterclockwise 2, 3, and 4, so that may help us. All right, what about this next one at 0, negative 2? So 0 is right here, and then we're just going to go down 2 for the y value, and that gives us this point at 0, negative 2. So if we asked you which quadrant this is on, it may be a little confusing, because it's not in any quadrant, really. It's really just on the... This is the y-axis. So we'll just write that in. The next point we'll put in green. At negative 1, negative 3. So the x value is at negative 1. The y value is at negative 3. That gives us this point at negative 1, negative 3. And which quadrant is this one in? Yep. 3. Last up, we got this at 1, negative 5, 1. Oh, it's kind of right there. 1, negative 5. Yeah. And this is in quadrant 4. Bam. Be very careful on the test to emphasize that V right there, because sometimes it looks like this, and then you lose points. But we don't want you to lose those points. We want you to get those points. Plot the points. Determine, this is the same idea on this one. Okay, we can do that. We'll start with red again. Negative 2 and 3. Negative 2, 3. Bam, right there. We'll even label it at negative 2, 3. And this also is in quadrant 2. Different. Okay. Then we got 3, 4. 3, 4 right here. And this is in quadrant 1. Then we got 4, 0 right here, which is in quadrant, it's not in any quadrant, it's on the x-axis. Then finally 5, 2. 5, 2 right there. And again, that's in quadrant 1. Points that are solutions to an equation make the statement true. Okay, this is just like when we were solving equations, right? So if I had 5 equals, I don't know, 3x minus 4. The only value of x that would make this true would be, oh, what the heck is that? 3? Right there. Which means if I plugged x, or replaced x in the original, which is in black on this one, with 3, then I would get a true statement. The problem with this, though, is that we're not solving for one variable anymore. We're really solving for 2. So this becomes y equals 3x minus 4. Now, there's an infinite number of answers to this right here. One of those is what we just found right there, 3, 5. But also, we could use something like if x was 0, then negative 4. This would also give us a true statement, okay? because we're looking at this, the first value is the x value, and then the second one is the y value in these ordered pairs. So I would replace the x and y value with the value in that ordered pair and see if it gives us a true statement. Now this right here is called slope-intercept form. You may see stuff in standard form, which may look something like this. Negative 3x plus y equals negative 4. And these two solutions we've already found would make this a true statement also. It's not so important that you guys understand or know what these two forms are right now, but it will be very important a little bit later. Which points are solutions to the equation? Y equals negative 3/4 x plus 8. So we're going to take this equation, y equals negative 3/4 x plus 8, and this first one, 4, 5. That means that I'm going to replace the x with 4, and I'm going to replace the y with its corresponding value, 5. And I just got a question mark here just so I can see if it is actually true. Now you could put this in the calculator, just check, but we'll do it the old-fashioned way. Negative 3/4 times 4 is negative 3. And then I got plus 8 right there. Negative 3 plus 8 is 5. 5 does equal 5, that's true. So this one, I'm going to put yes. You can write a solution if you want, but that's more writing than I want to do. Now the nice thing about this is since that is a solution, we could put that on a graph, that point. And then if we find any other point that is a solution, we would graph that point, which would allow us to graph a line. Pretty much everything we do in this unit will be based on straight lines. So all we really need is 2 points, though we're going to ask you to do 3. So let's try the next one. All right, negative 2, negative 3. So the x value is negative 2, and the y value is negative 3. So we'll multiply this out. Negative 3/4 times negative 2. I'm going to simplify it to 3/2 plus 8. That's going to give us something a lot bigger than negative 3. So this one is not a solution. Now we got 8, negative 4. So the x value is 8, and the y value is negative 4. All right, negative 3/4 times 8 is negative 6. Again, you can do that in the calculator. And then negative 6 plus 8, does it equal negative 4? Nope, it doesn't. So this one also is a no. Finally, we'll try this negative 16/21. All right, so negative 3/4 times negative 16 is positive 12. Plus 8, that's close. We're so close, 20. 20 does not equal 21, so this one also is a no. 1 yes and 3 no's. Now I've got this written at the top, just again so we can actually do the checking on this. So I'm going to put a question mark on that, just so we know we're trying to figure out if it is true or not. So we'll start with this 0, 9 stuff. So I'm going to replace the x and y with their respective values. I'm using parentheses just, so we have these separated. That's a 9 right there, dang it. So my x is 0 and y is 9. Some of you guys don't need to go any further than that, but we can do it. 5 times 0 is 0. 9 times 9 is 81. 0 plus 81 equals negative 20. Nope, it doesn't. So this one is a no. All right, what about the next one? Negative 6/4. So I'm replacing the x with negative 6, the y with 4. So I got 30 plus 36. That's not going to come close to negative 20 right there. So this one also is no. Well, this last one, we got 3 and negative 8. Oh boy. Negative 15 plus negative 72. Nope, that's not going to get anywhere near negative 20. So also a no. Bam. Complete these ordered pairs so that they are solutions of the equation. This is just like solving regular equations, but it's going to change where we're solving for it, okay? So on this one, We got negative 8x plus 6y equals negative 24. And this first ordered pair, we can see the y value is 0 on this thing. So I'm going to take this y value and replace it with 0, and then solve for the corresponding x value that goes with it. Now the nice thing about this is anything multiplied by 0 is 0. Well, we don't really need to show plus 0 on this. So I've really got negative 8x equals negative 24. And we're not dealing with this inequality stuff anymore, so when I divide both sides by a negative, I don't have to worry about flipping anything. But I got x is 3. So that ordered pair would be 3, 0. Now we could plug, again, x just like we would in that first module. We can replace x with 3 and y with 0 just to make sure we get a true statement. And we do. All right, this next problem, we are replacing the x value with 0. So I'll go ahead and do that. Replace this x value with 0. And again, anything multiplied by 0, that's just going to be 0. Nothing else changes. But again, we don't really need to show that plus 0 stuff. So to solve this one, we'll divide both sides by 6. And we get the y value, its corresponding y value is at negative 4. On the graph, we see these, and I don't remember if this was on the homework yet, but it will be eventually. That 3, 0 right there, that is where the line would cross the x-axis. And then the second point there, 0, negative 4, that's where it crosses the y-axis. Those are important points, which actually I'll talk about here in a moment, okay? But let's look at this third point, where the y value is negative 3. So I'm going to go into the equation and replace the y value with negative 3. All right, so we got the y value replaced with negative 3. So we'll multiply this out, and we get negative 18. Now you could put plus negative 18 if you want, but I'm going to simplify that right now as minus 18. So negative 8x minus 18 equals negative 24. I would add 18 to both sides. Be careful with that negative 24 because it's going to, well, it may throw you off a little bit. This is going to equal negative 6. Well, we'll divide both sides by negative 8 then, and simplifying this, we get x equals a positive 3/4. So the ordered pair would be 3/4 negative 3. So let's just identify this on a graph, all right, because we do need to acknowledge some of this stuff. This is our x-axis right here, and this is our y-axis. Just doing this, just doing this freehand, so it's not going to look so pretty. But we still got this point at 3, 0. That's a first point that we had right there. Now again, that's where it crosses the x-axis. That is called the x-intercept. The next point, which was at 0, negative 4, would be down here, right there. Okay, now we know we could make a straight line with 2 points. Okay, this one that crosses the y-axis is called the y-intercept, because it's where it intercepts the y-axis. Now just to confirm this, because you should do this and always do this, we should write this next point, the 3/4 negative 3, which, I don't know, it can be a little bit difficult to identify. But this one's not too bad. 3/4 would be about right there, and then negative 3, about right there. Now, if this was proportional, if it was drawn to scale, the line that I draw through those points would go through all 3 points. Okay?